Alrighty guys, this video is over significant figures. Make sure you thoroughly understand significant figures because they're going to govern all your answers for the rest of the year. And if you don't put your answers in the correct significant figures, you're going to have points deducted. So please make sure you understand this and don't forget them because they will come back to bite you if you don't learn them now. So, first thing we got to do, define significant figures. What are they? Their significant figures indicate how much confidence or estimation of a measurement is known. So confidence goes in this blank. Okay, there are 4 rules to these, and make sure you memorize them or at least know how to use them, or show us that you know how to use them. So the first rule is non-zero digits are always significant. Okay, that should be easy. So 24 has number 2, it has number 4. Both of those are obviously non-zeros, they're both significant. So we say that has 2 significant figures or sig figs. The second rule, leading zeros are never significant. Take the example down here, 0.0024 only has 2 significant figures because all of those zeros are in front of the non-zero numbers. If that doesn't make sense, you can do something like 100. Obviously that 0 doesn't matter, it's still 100. Or 555. That 0 obviously doesn't matter, still 555. The third rule, middle or trapped zeros are significant. They still hold value. So you take the number 204. This 0 right here still holds value. Says there. So 204 has 3 sig figs. If it's trapped in the middle, it counts. And the fourth one, tailing zeros are significant if and only if there is a decimal point. So 24.0 has 3 significant figures because of that decimal point right there. 240 only has 2 significant figures. Now, another tricky thing you might see is if you see the number written like this, 240 decimal point. Well, since that decimal point is there, this number still now has 3 sig figs. Some people find that kind of tricky. So make sure you understand how to use those. Use these, write them down, memorize them, because they will come back and you need to know them. Next, let's go ahead and practice. I'm going to do these first 4 for you. When I'm done, I want you to pause and work on numbers 5 through 8. So count and underline the sig figs in each of the following numbers. So 4,000. These zeros are tail zeros, and there is no decimal, so there's only 1 sig fig there. So 1. 0.0045. These are leading zeros, so they don't matter. The only sig figs are 4 and 5. So this has 2 significant figures. Number 3. These don't count because they're leading, but then you have a 9 and a 9. And the 0 trapped in the middle. Remember, trapped zeros hold value. So this one has 3 sig figs. Then number 4, this is an exponential notation. Sorry. We don't care about this part. So you can just kind of mark that out. But we have a 2, a 0 in the middle, and 1 at the end. Since I have a decimal place, all of those zeros matter. So we have 4 sig figs. So go ahead and pause it and work through 5 through 8. Make sure you know what you're talking about. I'll run through here in just a bit. That one has 3 significant figures. Okay, be sure you know how to round. Take this first number. We're going to round it to 3 sig figs. So 1, 2, 3, 4, 5, 4, 9, 9. So 1, 2, 3. Those are your 3 significant figures. And they have to check the next digit. If it's less than 5, this number stays the same. If this was a 5 or up, then this 3 turns into a 4. But since this is a 4 right here, we'll just stay at 123,000. Now this one, the negative sign has no effect. So we have 2, 3, 4. There are 3 significant figures. And you look at the next to last digit. That's a 9. 9 is greater than 5. So this 4 will go up. So that turns into negative 235,000. Then number 3. That 0 doesn't count. Then you have 2, 3, 1. Look at the next number. That's a 4. 4 is less than 5, so this 1 stays the same. So it just is 0.231. And the last one. 1, 2, 3 non-zeros. Look at the last one. That's a 9. 9 is greater than 5. My board is out of calibration. So that 9 will bump that up to a 10, which would then bump that up to a 9. So this turns into 19.0. If you're having trouble with rounding, get with your teacher. They'll fix you up real quickly. Now, obviously, you've got to be able to do math problems working with significant figures. The key thing is the answer can have no more significant figures that are in the measurement with the fewest number of significant figures. And then exact numbers, such as counting numbers and conversion factors, are not included when counting sig figs. But this is the key statement that's going to govern you when you're doing your math. You're going to find the measurement with the fewest number of significant figures, and that will dictate how many sig figs are in your answer. So let's go ahead and work through these. I'll do numbers 1 and 3. I want you to try numbers 2 and 4. So if you would plug this into your calculator, number 1, you would get some kind of crazy big answer. But how many sig figs? You can determine how many significant figures are going to be your answer right off the bat. This first one has 1, 2, 3, 4 sig figs. 32 has 2 sig figs. Then you find which one has the fewest amount. So 2 is obviously smaller than 4, so your answer is going to be in 2 sig figs. So you plug that in your calculator, you get some big number, but you only need 2 sig figs. So that gives you 0.00021. I'm going to do number 3. If you put this into your calculator, you get a big number. But how many sig figs are the first number? 1, 2, 3, 4. That has 4 sig figs. 25.2 has 1, 2, 3. So how many sig figs is your answer going to have? It's going to have 3. It's the lowest number. So you plug this into your calculator, you get 715.68. Going to 3 sig figs, it's 7020. And make sure you don't put that decimal there. Remember, this is 1, 2, 3. This is the trapped 0, so there's 3 sig figs. Go ahead and pause it and do 2 and 4 on your own.